All right, so let's go ahead and begin in prayer. In the name of Father, Son, Holy Spirit. Hail Mary, full of grace, the Lord is with thee. Blessed art thou amongst women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners now and at the hour of our death. Amen. All right, welcome to day 2 of live classroom experience in geometry. Today our objective is to solve inverse trig problems. Okay? Instead of taking the tangent of an angle and getting a ratio, we're going to look at, if we know the ratio, how can I find out what angle produced that ratio? So we're going to go backwards today. All right. So your homework is in your class announcements now. When you open it, the first thing you'll see is the solution to today's homework. Okay, that'll be the normal presentation. You'll get the solution for the previous homework first, and then if you scroll down, you'll see the homework that's due for the following class. We do not have class on Friday, but that's when the homework is due. The homework is due Friday by 9 o'clock. I did that on purpose because we're going to have a quiz Friday. My office hours on Friday are at 9 o'clock. So if you have any questions, I'll be able to address those questions because I'll be able to see your homework. You can come on my office hours at 9 o'clock and we can make sure that you're ready to take the quiz.
When's the quiz due?
What's that?
When's the quiz going to be due at?
Okay, the quiz is on Friday. We don't meet Friday, okay?
Yeah.
So I will post it by 9 o'clock. So that way, if you have trouble accessing it, you can just hop on my office hours and say it's not working. Maybe I messed something up. And it's going to be due on Friday by midnight. Okay, so you have all day Friday to work on it, because I know you're going to be given different requirements to do. Just have to make sure it's in Dropbox by midnight. Okay, and that's very important because otherwise it'll count as a no submission. All right. And one of the most important parts is going to be showing work. All you do is write down the answers. You're going to do very poorly on this quiz. You'll get below a 50. I'll show you exactly in the example problems I go through what you have to show to get full credit on the quiz. And it's very similar to what you did for your homework today. So if you did well on the homework today and showed all your work, which most of you did, your work looked very good, you should be all set for the quiz. All right. Any questions on the homework, where to get it, or the quiz on Friday before we get started? Everybody good? Hector?
Is it going to be a daily quiz or a regular quiz?
No, this is a regular quiz. It's not a daily quiz. Okay, so this is one that's going to count a lot more than a daily quiz.
Sir, I didn't hear what you just said.
What's that?
You muted out for a couple seconds, so
Okay.
I didn't hear what you said.
This is not a daily quiz. This is a regular quiz. So it's worth a lot more than a daily quiz. Okay, so that's why I gave you a lot of time on Friday to work on it, show all your work, and you should be able to do very well on it, especially if you're able to understand the homework for today and today's class.
So you'll go over what it's going to be on today, right?
Exactly. Yes.
All right.
Most of it's going to be on what we've already covered, the 45, 45, 90, Pythagorean theorem, 30, 60, 90. But remember, all those problems can solve by trig.
Mm-hmm.
So if you really understand how to do trig in today's class, you'll be all set.
Okay.
Okay, other questions? Good question. Yes, Charles.
So I wanted to ask a question on the past homework. So the difference
today?
Yes, this sheet.
Okay, I'm going to go over one of those problems for everybody in just a minute.
And then should I ask?
After I do that, if you have any follow-on questions, let me know.
Okay. All right.
Okay. Let's see. Hold on, I lost everybody. Let me get you back. All right, any other questions before we get started? All right, good. On the homework, the problem I want to go over is problem number 5. Okay? It was a problem where you were given a right triangle, where you knew this angle was 49, and the side across from it or as we now know, it's called opposite in trig terms, was 14. I want to go over how you find the hypotenuse, which would be y on your homework. All right. So if I want to find the hypotenuse, the very first thing I have to understand is where is my reference point? Out of A, B, and C, what are my two options of where I can stand?
A and B.
A or B. I can never stand at the 90-degree angle, because if all I know is that it's a 90-degree angle and I don't know these two angles, I don't know what trig function to use. So I'm going to go over this example first, standing at A, and then over here we're going to stand at B. And you'll see that you get the same answer either way. You just need a reference point. So I'm going to physically stand at A. Okay, here I am. I'm standing right here at A. When I do that, what side is this?
Adjacent.
Adjacent. What side is this?
Opposite.
Opposite. And the hypotenuse is always the hypotenuse. It never changes. It is always the side across from the 90-degree angle, whether you're standing here or here. It does not matter. This is always the hypotenuse. So now I need to look at this problem. I don't know anything about the adjacent leg. I do know that my opposite leg is 14, and what I'm trying to find is the hypotenuse. So I have to say, what trig function links opposite and hypotenuse?
Sine.
That would be sine. So I can say that the sine of A, which is 49 degrees, and remember, what does sine of 49 mean? Sine is a ratio. Sine tells you what ratio you're interested in, opposite over hypotenuse. And it's real important that the angle tells you where you're standing. You have to stand at the angle that you put here, okay? So this is a ratio. So it is equal to a ratio, and it's equal to the opposite over the hypotenuse. So the opposite is 14, and my hypotenuse is y. Okay. Why is it important to get this? Because this is now something I can use to solve for y, because this is just a number that I can get in my calculator. When you take the quiz on Friday, there are many different answers there are few different answers you can put here, because you could stand up here and get a different equation here. This equation is worth half the points on the daily quiz. Okay, so if you have a proper equation like this, where you say sine, cosine, or tangent of some angle is equal to some ratio, and it is the appropriate order that matches your picture, you have half the credit for that problem. If all you do is put down an answer and you don't show this, you will lose half the credit for the problem. So if you don't show this for all the problems, you're going to get a 50. All right, so this is really important to show. The next thing you have to show me is how you solve for y now. Okay. Most of us feel comfortable making this a ratio and this a ratio, because this now is a proportion. I know how to solve proportions. I cross multiply. I can say that y times this, the sine of 49, and remember, the sine of 49 is a number. These two go together. You can't break them up, okay? Is equal to 1 times 14, which is 14. So this is just a number, and this can't be broken up. If I wanted to solve for y, I need to get rid of this.
You divide it, right?
If I have a number times y, and I want to solve for y, what do?
Divide.
14 over.
I divide by that number. This is a number. Okay. That cancels, so now I get y equals, all right, let's make sure our calculator's in degree mode. What is 14 divided by sine of 49?
18.55.
Okay, 18.55. And there's your answer, okay? So the key things to get full credit on the quiz is to show me this setup, show me how you solve for y, and write the answer, okay? These three things will give you full credit on the homework, on the quiz problems. Any questions on that? All right, good. Now, let's look at that same example over here. And instead of standing here, let's say I chose to stand here. Okay, I want to stand at B. That's not a problem. It's just a reference point. Okay, so if I'm standing at B, now AC is what side?
AC is
Opposite.
But it's
Opposite.
the opposite because it's
Yeah.
across from where I'm standing. See, this is my reference point. 14 is now the adjacent, and this is still the hypotenuse because that's always the hypotenuse. It's across from the 90.
So
now
wouldn't that
what's that?
wouldn't that be like x over 14 or something?
Well, let's see. What I now have to decide is if I'm going to use sine, cosine, or tangent. Let that decision determine what ratio you need. Okay, if I'm standing here, what do I know? I know the adjacent, and what am I trying to find out? The hypotenuse. So I need a trig function that links adjacent to hypotenuse. What ratio is adjacent to hypotenuse? Sine, cosine, or tangent?
Cosine.
Cosine. So I'm interested in the cosine function because that's what relates adjacent to hypotenuse in ratio form. So I want to know the cosine. Let's split this out. I want to say that the cosine of where I'm standing, what goes here? Oh, I don't know. Or do I know? What I'm standing at B, what goes in here?
41.
41. How'd you get that?
Subtract 49 from 90.
Right, because I know these two have to add up to 90 because this is 90 and 90 and 90 is 180. That's the easiest way to do it is just check these two angles always have to add up to 90. So if you're standing here, I cannot put 49 here because 49 belongs over here if I'm standing here. So I would say the cosine of 41, okay, remember cosine describes the ratio you're interested in this case, adjacent and hypotenuse, when you're standing here. I'm standing here. So the ratio determined by cosine is adjacent over hypotenuse. So what goes on top?
14.
The 14, and the y goes on the bottom. Again, this is what's going to give you half the credit for the problem. Make sure you write that down. That tells me that you understand how to set this problem up. Okay, now we have to solve it. Again, the easiest way to solve it is to make it a proportion. Y times the cosine of 41 is equal to 1 times 14, which is 14. So y is equal to 14 divided by cosine of 41, and you will get y to equal, you should get y to equal the exact same thing. Is that true? Go ahead and do this on your calculator. 14 divided by sine of 41. And you get 18.55 again.
I have a question really quickly.
Okay. Somebody, let me just get somebody to confirm this for me.
Yeah, it's 18.5. You're correct. Yep.
Okay, good. All right, good. So now what I want to do is entertain your questions on this. Charles, what do you have?
So I think I got the first part correct, but the second part, so I use cosine because I'm trying to relate the adjacent over the hypotenuse. Is that what
You
you're
need
trying
to find x. I'm not sure I understand your question. Is it that you're trying to find this leg now? Charles, can you hear me? I think I lost you.
Okay. Yeah, it says my internet connection is unstable. Never mind. Well, I was trying to ask, could you go over, I missed, so why would you use cosine again? I missed that.
Because in this problem, I decided to stand here, didn't I? Okay. If I'm standing here, what do I know about the sides of my triangle? I know this one's 14. What is it that I'm trying to find?
Y, I guess.
Y, which is the hypotenuse, right?
Yes.
So I know the adjacent and I'm trying to find the hypotenuse. Well, let me just slide over here. So if we look at SOHCAHTOA, okay, this acronym SOHCAHTOA, and that's on your formula sheet, right? I'm interested in, I know the adjacent and I'm trying to find the hypotenuse. Does this talk about the adjacent and the hypotenuse?
No, it's
Does this talk about the adjacent and the hypotenuse? Yes. That's why I use cosine, because that cosine makes a ratio out of the two things that I'm interested in. One of them I know and one of them I don't know. Because what I'm trying to figure out is a way to find out the one I don't know.
So can you pick any of them to do?
No, you gotta find the hypotenuse.
Well,
You gotta figure out which one it goes to.
Yeah, what you have to do is, I could not use, if I'm trying to find the hypotenuse, I can't use tangent, because tangent's what? Opposite over adjacent. There's no hypotenuse in there.
So, but do you get to pick like where you start at? Like you said, you stand it. You get to pick.
You always get to pick where you start at, and I would pick that first, because that defines everything for you, okay?
So it doesn't matter where you go. You can pick anywhere.
You just can't go to C. You can go
can't stand on the right
anywhere but the right angle. So you only really have two choices.
so I have a so you already what's under AC? What do you have under there? I can't see that. Does it say opposite or something?
This
AC.
one, yeah, it got the opposite side. Because
Okay,
if you're
so
standing here, what side is opposite or across from you?
AC.
This one. What side is next to you or adjacent to you? This one. And see, and that's real important, because you got to know that 14 is the adjacent, not the opposite, because now I can use that to figure out what trig ratio I have to use. I have to use the one that links adjacent to hypotenuse.
Because there's no hypotenuse over, there's no.
Cosine is adjacent over hypotenuse.
Okay.
So I have to use the one that links those two.
And there's only one, right? When you're in respect to B, there's only one, right?
Correct. There's only one that's going to link these two. That's correct.
All right. I think that's what I was trying to ask.
See, when I stood down here, what linked the two, what I knew and what I was trying to find was sine. When I moved up here, what linked what I knew and what I was trying to find happened to be cosine.
Okay. All right. I think that.
So you have to, that's why I draw a little person there. You have to imagine you're standing there and this side is across from you, this side is next to you. And the hypotenuse never changes. It's always H.
Okay, I think on my homework, I got 1 through 4. I did that correctly, but 5 through 8, for some reason I put in tangent for the second to find.
Okay, well, just go back. I would try to, you have the solution now, so I would rework those with the current understanding you have, just to make sure you got it before you take the quiz.
Yeah.
And if you do have a question, just hop on my office hours, either today or Friday morning at 9.
Okay, sorry. Thank you.
Okay? All right, any other questions on this problem or any of the other homework problems? All right. There's one other thing we need to introduce about sine, cosine, and tangent. And that is, what if I'm trying to find the angle that produces these sides? All right. So I'm going to open that up for discussion. Does anybody think they could find out what angle that is in this triangle if I knew it was a right triangle and my sides were 8 and 15? Anybody have any ideas?
Pythagorean theorem.
Pythagorean theorem you can use to do what? To find the length of this hypotenuse.
Yeah.
There's nothing wrong with doing that. It's a right triangle. So you can use the Pythagorean theorem tool on this problem, and it'll give you this side. The only problem is that's not what I'm asking for. I'm asking for this angle. Charles.
Can you do something like, if you let like f of, or like, can you do 8 times whatever you're trying to find, so cosine, sine, or tangent times theta? Can you do that?
Well, not times theta. You can go times a trig function of theta.
Okay,
well,
I think, or is it, did I
If I
switch?
told you what this angle was, okay, let's imagine, let me give you a hint. Let's imagine we're standing here, okay? If I'm standing here, what trig function relates these two sides?
So it's
If I'm standing here,
opposite or
this is
adjacent?
what side?
Tangent.
Is
So,
this
yeah,
opposite or
tangent.
adjacent? If I'm standing here,
Opposite.
this is what?
It's tangent.
Opposite, and this one is adjacent. So which trig function relates the two things that I know in this problem? Opposite and
Tangent.
adjacent.
Tangent.
Tangent. So
Yeah.
can I write this? The tangent of my angle that I'm trying to find is what? Is 8/15, right? Because tangent is this ratio, opposite over adjacent. Opposite over adjacent is 8/15. Do you think I'm okay to write that? If I knew what this angle was, couldn't I say the tangent of that angle is 8/15? Would everybody agree with that?
Yes.
Okay, if you put 8/15 in your calculator, I think you get around 0.533.
Oh, and from there you can do, couldn't you do 15 times the tangent times the angle? Then that gives you
Well,
what you're trying to look for.
The problem is, remember I said this is all one. You can't break this guy up, can you?
No.
So
you
I
can't.
can't divide by tangent and just leave theta here. I can't do that. I can't break this guy up.
No, I mean, no, I'm not talking about breaking it up. I think, oh wait, you already have 8. Never mind.
Well, you have it. Most everybody has their calculator, right?
Yeah.
Just take a guess. Chris, what do you think? You think this angle's bigger than 45 or less than 45? If this is 8 and this is 15. You think this angle's bigger than 45 or less than 45? Chris, can you hear me? Unmute yourself. Or anybody. Just take a guess at what you think that angle might be.
Like around 30.
30, okay. Well, let's try
I was gonna
30.
say something like 35, 40.
So let's use 30.
28.07.
Use your calculator. What is the tangent of 30? Did you get 0.577?
Yes.
Was it right? Well, 8/15 is really 0.533. So that's pretty close, isn't it? It's pretty close.
Said 0.57.
It's 0.577, yes.
Yeah, that's what I got.
Okay, but it's not 8/15. It's close, isn't it?
Yes.
How do you want to change it to try to make it closer? Maybe go tangent of 29? See, I can keep guessing and see when what's the
That's
tangent of 29?
That's 0.554.
Okay, that's pretty close to 8/15, isn't it?
28 is 0.531.
0.531 is.
I think that's the closest you'll get.
Okay, so so beta is probably real close to 28 degrees, isn't it? So do you see how I can use these numbers and tangent to kind of figure this out? But the nice thing is
28.1 is 0.5, or 28.1 is 0.5339.
okay. All right. So do you see how we can use the calculator to try to figure this out? But the nice thing is all these numbers are already in your calculator. We don't have to search for it. There's an easier way to figure this problem out. Let me show you why. Okay. And we really have to understand that tangent is a ratio. Okay. Tangent is a ratio. And we always take the tangent of where we're standing, which is an angle. Over there, we took the tangent of an angle always gives you a ratio. Would everybody agree with that? On your calculator, look at the tangent button. Above it, you probably have something like this written, inverse tangent. Everybody see that? Does everybody see the inverse tangent button on the calculator?
No, I don't
Yes.
have that.
No, I don't see it.
Okay, here's my tangent button. And right above it, right above tangent is tangent inverse. Okay, if you have a tangent inverse function on your calculator, okay, go ahead and raise your hand. Who has a tangent inverse?
Oh, it's a little blue thing above it. Yeah.
Right, the little blue thing above it. Do you see that?
Yeah.
Okay, that makes a problem like what we just did very easy, because what tangent inverse does is that if you take the tangent inverse of a ratio, it's going to tell you what angle produced that ratio.
Wait, so if you say that button and then you're 0.533,
Exactly. So all you have to do is do the tangent inverse of 0.533, and it's going to give you the 28.1.
28.57.
There you go, and it rounds off to 28.1.
Yep.
So that's pretty nice, isn't it? All right. So if you're given the ratio and you're ever trying to find the angle that produced that ratio, all you have to do is the inverse tangent, and you can put it in as 8 divided by 15 as long as you put it in parentheses. That way you won't have any round off error. It'll give you the exact answer. I think Chris said it was 28.5 what, 7?
Let me pull it back up. 28.057.
Oh, okay. Yeah. 28.06. Okay, and that rounds to 28.1. So does that make sense to everybody? So you really want to make sure, if you don't have a calculator that has inverse tangent, then you're probably going to have to do it this way and just kind of keep searching until you find it. But that can take a while.
Sure.
But there's nothing wrong with doing it that way. Guess and check. But if your calculator has the inverse button, this becomes very easy. Okay. If you ever want to know what angle produces a ratio, you just use the tool that goes backwards. Because remember, if you think about a function as a factory, okay, if I call this my tangent trig factory, what does it like to do? It likes to take an angle, it likes to take the tangent of it and produces a ratio, right? What the tangent inverse does is it's like taking the answer and going through the factory backwards to say, here's the angle that would give you this answer for tangent. Okay? That's why we get over here, if you always take the inverse tangent of something, you're going to get an angle. If you take the tangent of something, you're always going to get a ratio. Okay, does that help put it in perspective for you? Okay, so that's the last thing that we need to talk about: trig, sine, cosine, and tangent. And you can do this for any trig function, sine, cosine, or tangent, not just tangent. You can go backwards for any of those 3 trig functions. All right.
Mr. Rumbolsky.
Yes.
So I found a way for how to get the inverse tangent for calculators that don't have that tangent -1 button. So on my calculator, I have a thing that it's like blue. It's a blue thing above one of the numbers, and it says second. So you press that, then you press tangent, and that gives you the inverse tangent.
Correct, because you have the older model calculator, but notice it still does it right above the tan button, doesn't it? In more modern day calculators, it actually writes it on there for you. Okay. On yours, it may not be written there. It was just understood that that's how you go backwards. You go above the button.
Yeah, you do. It's a second. It's on a button. It's like second function or something like that. So I press that, then I press the tangent, then something shows up that tells me it's the inverse.
Okay, and on most of the more modern calculators, it has a second button. On most of the calculators, it's in gold. And whenever you hit the second button, you're looking at what's written above the keys, and what's written above tangent is tangent inverse. Okay, So let's go through a problem to make sure that we understand it. All right, so here's a problem where I know I have a right triangle. I know one side is 6 and one side is 9. What I want to do is I want to find the hypotenuse and my other two angles. Okay, what do you want to do first? Any ideas? What do you want to do first?
Pick where you're going to measure from, or
What's that?
pick where you're going to stand in order to.
Okay, well, first we need to decide, what do you want to find, X, Y, or Z? Which variable do you want to find first?
Z, because you can just use the Pythagorean theorem.
There you go. I would find Z first, because that's easy to find. I know A and B, right? So I know that 9 squared plus 6 squared is Z squared. Okay, so if I do that, go ahead and do that in your calculator. Really, all you got to do is 81 plus 36 and take the square root of it. What do you get? Go ahead and do that in your calculator. Tell me what you get.
10.81.
10.81.
Does it round off to 8.2 or 8.1?
Yes.
8.1?
2. Yeah,
Yeah,
10.82. 10.82.
it rounds off to, never mind.
Normally, for round off, if you're getting an angle, the most I'll ask you to do is to round off to the 10th. And if you're doing a side, the most I'll ask you to do is to round off to the nearest 100. 0.82 is the nearest 100. So now I have my 3 sides. And I have one angle. I know it's 90. So all I really need to do is figure out X or Y. Because once I know one of them, it's easy to get the other one, isn't it? All I have to do is what? Subtract it from 90. So now is where I have to decide which one I want, X or Y, and I have to figure out where I want to stand. Okay? All right. So, Ryan, where do you want to stand? Let's call this A, B, C.
A.
A, B, or C?
A.
A, okay? I'm going to stand at A. So here I am. So if I'm standing at A, what side is this? Hypotenuse, opposite, or adjacent?
Adjacent.
That'd be
opposite.
opposite. And that's
This is
adjacent. That's adjacent.
Yeah.
And this is always the hypotenuse. Okay. Now, if I was going to find X, I can use any one of these 3, can't I? All I need is 2 of them.
Mm-hmm.
I would use these 2. I would not use this one because this answer was actually rounded off, wasn't it? So that's going to introduce a little bit of round off error in the problem. So I'm going to use the 6 and the 9. Another reason I'd use the 6 and the 9 is they're just easier numbers to use. Why use 10.82 if you can use 9, right?
Mm-hmm.
So
And you can like simplify the ratio as well.
exactly, because it's just a ratio, right?
Mm-hmm.
But
So that can be like 2 and 3.
It's
2 over
2
3.
over 3.
Yeah.
Right. But since I'm standing here and I now know I want to use these 2, what trig function do I want to use?
Opposite or adjacent would be
Which is?
sine.
Opposite over adjacent is what?
Sine.
Sine? No, sine is
That's
opposite over
Tangent.
hypotenuse.
Tangent. Yeah.
Tangent. So I want to use the tangent of what I'm trying to find. What I'm trying to find is X. That's my angle. You always take the tangent of an angle and get a ratio. What is my ratio?
9 over 6.
Is it
Wait.
9 over 6 or 6 over 9?
6
6
over
over 9.
9.
6 over 9.
Right. It's opposite over adjacent. So it's 6 over 9, or as somebody said, they know that just reduces to what?
2 over 3.
2 over 3.
Nothing wrong with doing that. Okay. Now, this is that situation where I know this is one entity. I can't break this thing up. So how do I find the angle that gives me an answer of 0.6667? I do what?
Over 1. Put it over
I
1.
have to use the tangent inverse,
Oh, yeah.
right, of 2/3, because if I'm going backwards, I flip these two, and that's going to give me my angle. So go ahead and take the inverse tangent of 2 divided by 3. And what do you get?
33.690.
So 33.7. If we round off to the nearest tenth, that would be 33.7 degrees, right?
Mm-hmm.
So this angle is 33.7 degrees, which means this angle now is easy to get. What would y be?
Wait, what did you get for that again?
It's 33.7.
33.7. Everybody agree with that?
Yes.
Hold up.
Yes.
Because all you're doing is you're taking the inverse tangent. In other words, you want to put it through the factory backwards. If the answer is 2/3, go through the tangent machine backwards and see what angle had to go into the factory.
All right.
Yeah, I
Everybody
got
agree at 33.7?
33. Yep, I got 33.7. Yep.
Good. Okay. If that's 33.7, this one's easy. Because how do you get that one?
Subtract 90 by 33.7.
And what do you get?
56.3.
Wait, hold up. I need.
Yeah, you get 56.3. Correct.
So now I have solved the triangle.
Wait, so how do I put that in my calculator? The tangent 1, 2/3.
There's
Well,
a
for my
second.
calculator, I just press second and then
Yeah, you just press second and then press tangent.
Right.
Yeah, should be there.
Press the second button first and then the tangent. What the second button tells the calculator is you want to go through backwards. So you go second tangent. That's what's going to do the tangent inverse for you. Does that make sense?
Can I do that on my phone?
I don't know if your phone does that or not. I can check after class.
Because I don't have
I'm not sure
a.
if the phone has that sophisticated of Trig software in it to be able to do that.
I think if you have an Apple, it does it.
Okay, yeah. The best thing to do is to get one of these right here, because you want to learn these keystrokes in a graphing calculator, because that's going to help you out a whole lot for next year. Okay, because I know what you're going to be doing next year you can't do in your phone. All right, so I have now solved this triangle. I started off only knowing 2 sides. I used the Pythagorean theorem to get the third side. I used my inverse trig function to get one angle, and then just subtracted it from 90 to get the other angle. That's what you're going to be required to do to completely solve a triangle, is pick different tools to find what you need to find out. All right, and you'll be able, and you may have a question like this on the quiz on Friday as well. In fact, you probably will have one where you're given, it may not be these two, it might be the hypotenuse and this side. Okay, but you will have to solve a triangle where all you know is that it's a right triangle and 2 sides. Okay, Charles, what do you have?
Oh, okay. Sorry, I wasn't sure if that was working, but so for tangent, that's just for the angle. You said that. Is that just to find the angle? You said, because you wrote tangent times the angle. Oh wait, you said tangent times the angle equals the ratio. Is that
right?
Is that just for finding the angle if you don't have the angle or theta?
Let me show you again. Let me go here. All right. You have a tangent button on your calculator, right? If you go tangent of an angle and hit enter, it gives you an answer. The answer it gives you is a ratio, right?
No.
Sure.
It gives me a decimal number.
A decimal is a ratio. 1/3 is 0.333.
Freaking tard.
No,
right?
no, I'm not. Okay.
Okay, does that make sense?
Yes.
When you take the tangent of 30, you're taking the tangent of 30 degrees and it's telling you what ratio that is. But
Yes.
your calculator's not going to express it as 1/3. It's just going to say 0.333.
Yes, I know how to I was just trying to.
But it's always over 1, right?
But yeah, but it's always over. It's going to, exactly. A decimal is just always, instead of 1/3, it's 0.33 over 1.
Yeah,
Same thing. Same
I
number.
knew that. I was just
When you hit that tangent inverse button, what you have to put next to the tangent inverse is the ratio. And when you hit enter, the answer it gives you is going to be the angle. It's going through that factory backward. Does that make sense?
Yes.
Okay. All right, good. Let's just try to set one more up to make sure we understand it. Okay, here's a problem. If I tell you this is 90 degrees, always make that check. Because if you don't see this, can you use sine, cosine, and tangent like we've been talking about? No, right? You cannot use sine, cosine, and tangent like we've been talking about if this is not 90 degrees. Okay, I now know the hypotenuse is 8, and I know this side is 5. I know that you all know how to use the Pythagorean theorem to find z. Okay, so we're not going to find that. Let's just figure out how we're going to find x and y. All right, so the first thing I have to figure out is where I want to stand. Okay, Matthew, where do you want to stand? X or y?
I'll do Y.
Okay, so I'm going to stand here. Okay? If I'm standing here, look at what I know. I know the 5 and the 8. What side is the 8?
Hypotenuse.
Hypotenuse.
What side is the 5?
Adjacent.
Adjacent. Okay, look at your trig functions. What trig function relates adjacent to hypotenuse?
Is it the cosine?
Cosine. So I know that I'm using cosine. Okay, and the cosine, what comes here? An angle. What angle goes in there? The angle you're standing at. What angle am I standing at?
Y.
The one I don't know. That's what I'm trying to find out. But I know that the ratio that I'm looking for is what? What's the answer?
Hypotenuse over
5 over 8.
yeah, 5
See,
over
now
8.
instead of the variable or unknown being over here, what I'm trying to find out is over here, and I know both of these. Well, that's okay. That's easy to do. If you know the ratio and you're trying to find the angle, go through the factory backwards. Take the cosine inverse of 5 over 8, and it'll give you the angle. So go ahead and do that real quick. What is the cosine inverse of 5 over 8?
51.317.
51.3 degrees.
Yeah.
Okay, and if I know this is 51.3, this one's easy. All I have to do is what? Subtract it from 90, and what do you get?
38.7.
38.7. I found my two angles. And if I wanted to find this side, you can use the Pythagorean theorem, or you could use a trig function, right? All right, any questions on that? We went through that one quickly, so if you need to watch this and go through it slowly, you can. Okay, so remember, I think we met our objective today of solving inverse trig functions. Okay, if you needed to put that homework in, make sure you do that. And then Friday, we do not have class, so make sure you make a note to look for the quiz. I will post the quiz by 9 o'clock. I will have office hours from 9 to 9:50, and you have to turn in your homework by 9 o'clock. So 9 o'clock Friday is an important time for you. Make sure your homework's turned in. Make sure you can download that quiz, because if you have trouble doing that, all you have to do is hop on my office hours at 9 to 9:50 and let me know. And remember, when do you have to turn the quiz in?
Friday by 9 o'clock.
Friday by,
9 a.m.
nope, by 9 a.m. is when it will be available to
Midnight.
download. When do you have to
Midnight.
have it completed and turn it back in?
Midnight.
Midnight.
By midnight, okay? And the important thing on the quiz is if it's a problem where you have to use trig, okay? I need to see this. I need to see your setup, where you're standing, what trig function gives you the ratio that will solve the problem. Show your work here, show your work here. The correct answer is worth very little as far as points go on the quiz. What I really want to see is how you set it up and how you solved it. That's the important part. All right. So we have about 5 seconds left. I'm going to go ahead and stop the recording. And if you have any individual questions, please stay on and we can address them at that time.